Hi students, let's look at this question which was taken from 2012, paper 1, question 10 of the H2 Math A-level paper. So there's given that the sphere of radius r has a surface area of 4 pi r square and volume is this formula here. So the model of a concert hall is made out of 3 parts. The roof is modeled by the curved surface area hemisphere of radius r, and the walls are modeled by the curved surface area of cylinder, radius r and height h, and the floor which is made up by circular disc. Right. So essentially, there's no ceiling here. It's just basically a dome, and after the cylinder and the floor. Okay, so 3 parts are joining together as shown in the diagram. The model is made out of material of negligible thickness. It's given that the volume of the model is a fixed value of K, and the external surface area is a minimum. Use differentiation to find the value of R and H in terms of K and simplify your answers. Okay, great. I think the main thing here is to understand there are 2 variables at play. Okay, so and there's one fixed condition. And usually this fixed condition is to use to relate both of these variables here. Alright. So I think at a glance, what we could deduce is the variables are H and R, right? At a glance. And the fixed constant which was given, which is a fixed volume of K cm cube. Alright, so the variables are R and H. Now, basically what we do is we just need to relate both of them by using this fixed volume here. Alright, so from here we can tell that actually the total volume K is actually equals to the area of a cylinder, which is the base area, multiplied by the height, right? Area of cylinder, and after which the area of the sphere, volume of a sphere, will be half of it. Okay, great. So volume of cylinder plus volume of hemisphere. Okay, so this case here, K is equals to pi r square h, base area times height. So if you have a cylinder here, what we could say is we just need to take the base area times the height, right? So then we'll get the volume. Then whereas for the hemisphere is half of 4/3 pi r cube. Great, so that's about it. So we have got this here. So we relate both of them by using this fixed condition. All right, so now once we relate ready, what we need to do now is to find the minimum of the external surface area using. So external surface area will be the area of the hemisphere, area of the cylinder, and area of the base area. Okay, so the base area, which is pi r square. So this case here, what I'm going to do is total surface area, total external surface area will be curved surface area of hemisphere adding curved surface area of cylinder and after which the base area of a circle to floor. So curved area of hemisphere will just be half of 4 pi r square, after which curved surface area of cylinder will be 2 pi r h, and the base area will be pi r square. So this case here, I think the main thing is to understand that we want to minimize this, but the problem here is that we have 2 variables. And we need to change this to one single variable so that we could just minimize it. So the case we just need to use this. I think it's easier to make h the subject here. All right. So I think it's easier to make h the subject here. So I'm going to just make h the subject from the previous condition. So the condition is to relate both of these variables. Here will be, I'm going to just move it around. So that will be h pi r square, make it the subject. Then once I have this, I'll be k minus 2/3 pi r cube. Then making h the subject will be h divided by pi r square, then will be k over pi r square Let's do that. So once this is done, I could just simplify this as k over pi r square minus 2/3 r. Great. So once this is, so now area here, what we could do is just substitute 1 into 8. The area could be simplified again, just 2 pi r square plus pi r square. So this is 2 pi r h. Then a would just be 3 pi r square plus 2 pi r h, right? Now you sub 1 into 2 because we want to change a into one single variable. So I'm just going to replace 1 into 2. So this case there, by doing that, my a will be 3 pi r square plus 2 pi r. H would be k. Then I'm going to simplify this. So multiplying in here, before I minimize it, what I get is 3 pi r square plus 2 pi r over pi r square k minus 4/3 pi r square. So 3 minus 4/3, I think is okay. Just key in calculator. So that'll be, a will be 5 over 3 pi r square, and after which 2 pi, that will be 2k over r. Okay, that's what I got. So now what I can do is actually dA dr to minimize stationary value. I know that dA dr is 0. So I'm going to just differentiate this 5/3 pi. I use dr because r is the variable. Then 2k, this will be negative 2k over r squared equals to 0. So now what I'm going to do is just make r the subject, right? Multiply this will be 10 to pi r squared, pi r, then this will be 2k r squared. Cross multiply. So r cubed will be 6 over 10 pi. That will be 3k over 5 pi. So from here, what we get is r is actually cubic root of 3k over 5 pi. All right. So because they want us to find r in terms of k. So now we're going to find h. Finding h shouldn't be an issue because we already have h here. This is the h here. So I'm going to just copy this down. So this case here may seem difficult, but I think it's okay. What I'm going to do is I'm just going to replace my r as 3k over 5 pi. This is cubic root, so I'm just going to be a third here. Okay. Then this case here, I'm going to square. So just remember that. Maybe I just put this like that. Okay, so I'm going to just put this over here. This will be r equals to 3k over 5 pi power of third. Then just replace it in. This is minus 2/3 3k 5 pi to the power of third. Now we need to manipulate this. This is actually just secondary school indices, right? It may look horrible, but let's just do it. This part here will be k. I'm just going to use secondary school indices law to try and solve this. Okay, so k, then this will be pi. This will be like 3. Maybe I just do this properly. Just k. 3 1/3. K 1/3. 5. Give me 2/3. Because it's 2/3, right? Yep. Then this over here, similarly, I'm gonna get 1/3. K 1/3. Pi 1/3. I think this becomes quite complicated. So I'm gonna just make this a single fraction. I think that will be much easier. So let's try this. H will be, this will be h equals to k minus 2 pi r cubed. Yeah, this is great. 3 pi r square. This is much easier, I think. Then r cubed will be easier because then we know that r cubed this will be h equals to 3k. We just make it a single fraction. Right, then this is 3k, which is minus 2 pi to 3k 5 pi. 1/3 power 3 will just be itself, and this will be 3 pi. 3k over 5 pi. 1/3 square. So this case here, what we get is 3k minus 2 pi. 3k 5 pi. After which, what we need is cancel this off. And what we get is that will be this is 3 pi. Yeah, I think this is much easier. So then from here, what I get from the top, 3k minus 250, that will eventually give me 9 over 5. 9 5 over k. And this will be 3 pi 3 2/3 over 5 2/3 k 2/3 and pi 2/3. Then this, the rest we just use, we just need to simplify it, right? But the good thing is, this I could see that this part here, this 3k over 5 pi 2/3. This is also 3k over 5 pi. So essentially, if I were to just rearrange this, it would be 3 over 5 k over pi. Yeah, great. This is much faster. So this is 2/3, this is 1. Essentially, this will give us 3 over 5 k over pi. 1 minus 2/3, which is actually just a third. So this case here, h would be 3k over 5 pi 1/3. And r equals to the same amount. Oh, okay, great. Okay, that's it. So that's the first part. Pretty interesting question, I think. So let's look at part 2. It is given that instead that the volume model is 200 cubic centimeters and external surface area is 180 cm square. So the two possible values of r is this. Okay, I think this has nothing to do with maximum and minimum now. So we need to show the volume will be, we know that the volume is 200, which is pi r square h plus half 4/3 pi r cube. The surface area, so the surface area which we found just now, surface area 100 centimeters square would be actually pi r square plus 2 pi r h plus half of 4 pi r square. That would be the surface area of hemisphere. Okay, so now we just need to solve this simultaneously because we have two unknowns here. Okay, so this case here, what I'm gonna do is actually just gonna take out the 200. Make h a subject. I think h is the easiest to make it a subject, right? Here too. There you go. So that will be pi r square h equals to 200 minus 2/3 pi r cube. So h will just be 200 minus r cube divided by pi r square. In this case here, I'm going to take 1, sub into the second one. So 180, that will be 180 equals to pi r square plus 2 pi r h, which is 200 minus 2/3 pi r cube over pi r square plus 2 pi r square. Right, that's about it. So cancel it out, give it r. In this case here, what is left behind is essentially 180 3 pi r square plus 400 pi by cube divided by, okay, maybe put this as 400 minus 4/3 cube divided by r. Okay, that's about it. Then what I'm going to do next is I'm going to just multiply each of these by r. And then what I'll get is essentially 180 r equals to 3 pi r cubed plus 400 minus 4/3 r cubed. Okay, maybe could have multiplied by 3, but okay. This case here, so this case what we get is essentially 5/3 pi r cubed minus 180 r plus 400. So from here, what I need to do is actually just key in GC. So this is go to apps and simultaneous equation. Simultaneous equation solver. Then we have 3, 1. Sorry, it's not simultaneous. It's polynomial root finder. 3. Then we just key this 5 pi over 3. The x. Then the second one will be 0. Then that will be negative. This book is minus 180 and plus 400. Then we'll solve it. We'll get from GC r is equals to, because it didn't ask for exact, so this is negative 6.7587 r. So these are the 3 roots. Obviously you reject this. This is rejected as r is bigger than 0. So hence r is equals to 3.7215 cm or 3.0372 cm shown. Okay, r has 2 possible values. Okay, then after which we need to find out r has 2 possible values, right? Shown 2 possible values. Then given that r is less than h, find the value of r and the value of h. So we just need to find out. So when r, so using this formula here, h is equals to, so what you do is when r equals to 3.7215, then using this formula, h is equals to, just key in calculator, 200 minus 2/3. Just key in here. This would be 2.1156. Then when r is equals to the other one, then this case here will be 4.8765. Okay, so since we are given that r is less than h, so hence we need to pick the one which r is lesser than h. So this will be the case. So hence thus r equals to 3.04 cm and h equals to 4.89 cm. 3SF. Okay. Yeah. So that's how you do this question here proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.